Hello, I'm Linda Strande, head of the Sondeck department at Eawag. My presentation today is about key issues to consider for an integrated approach to estimating greenhouse gas emissions. My slides are a bit dense because I'm using the same slides for my longer presentation on Wednesday into how sanitation can help meet the global methane pledge session in order to entice you to also participate in that session. Shown on this slide are preliminary results of the PhD research of Kelsey Shaw. Kelsey has flux measurements from 41 containments in Kampala, Uganda, and Vancouver Island, Canada. Based on her preliminary results, you see they are comparable to the SCARE data, other values in the literature, and are much lower than IPCC values for Scope 1 emissions. However, one problem with comparing to the literature and for scaling up is that these values are reported as per capita, calculated as the total number of people that have access to or regularly use a toilet. But it's not clear with non-sewered sanitation exactly what a population equivalent means. If we're talking about households and people are only home for 12 hours a day, then should they rather be counted as half a per capita for that toilet or containment, which would then double these per capita emission estimates? Or is it safe to say that people are defecating mainly in toilets where they sleep at night, so population equivalents should be counted at home? We must also consider that half the wastewater in a city comes from non-household sources. And as people are using other toilets throughout the city, such as offices, public markets, or restaurants, how is that counted towards the per capita estimates? Another important consideration is that we're talking about point source measurements, meaning they're taken at one point in time. And here we can learn from the last 15 years of experience trying to make reliable projections of quantities and qualities, or Q and Q, of fecal sludge from community to citywide scales. And fecal sludge or stored wastewater in urban areas has highly variable Q and Q. This is shown here with COD on the y-axis on a log scale compared to VSS to TSS for fecal sludge. Those are the blue, dark blue, and green dots, in comparison to centralized sewer-based wastewater, the orange dots. So you can see from the figure that if you take a single point source sample, there's no way that it's going to be representative of this whole huge wide distribution of values, which is obviously also the case for greenhouse gas emissions. Properties also do not follow a normal distribution, with standard deviations commonly reported to be as high as average values. Therefore, we need to identify other statistical patterns which can then be used for more accurate weighted averages or other more complex modeling approaches. Finally, when considering emission factors and how much organic matter is converted to greenhouse gases, there's a common misconception that organic matter in fecal sludge is being completely degraded during storage, and that time since last emptied is a predictor of the level of stabilization. This does not hold up to scientific investigation and is not a valid assumption. Field and laboratory research data suggests that during the first week or two of storage, there's maybe around a 20% reduction in volatile solids or COD, and then stabilization plateaus and is not predictable. The amount of degradation that occurs is very important to consider for emission estimates, as degradation is obviously directly linked to amounts of gases produced. What we see in the figure on the right side are PhD results of Nita Makbul. I won't go into detail on them here, but they also further support the level of stabilization occurring in on-site containments, and that IPCC Scope 1 emission and conversion factors are probably too high. So for more details, please see the session on Wednesday. You can also refer to my Nature Water review. You can access with the QR code here, and I'm looking forward to talking to you more in person at the meeting today. Thank you.